Hello, my name is Professor Johnson, and today I will show you how to make an equation of a line and write it in standard form. So first things first, what is standard form? Standard form is the form ax plus by equals c. Letter a, b, and c integers, and the most important part is this ax piece we want to create, or we want to make sure that it's positive. Okay, but to make an equation of a line, we need to first find slope. Slope is the first thing we need to find. Even before I read the problem, I know slope is what you need to find first. So our problem is find the equation of the line in standard form that passes through these 2 points, 3 and 11 and negative 2, 4. Now keep in mind, x1 and y1 will treat as the first point, and x2, y2 will treat as the second point. Do you remember the slope formula? Think about it. The slope formula is change in y divided by change in x. So change in y, you'll take the difference of the y values, y2 minus y1, and change in x, you'll take the difference of the x values. Now let's plug in directly what these values are. y2, if we look over how we labeled it, we get 4. Subtract y1 is 11. Divide that entirely by x2, which is a negative 2, and x1 we have to subtract 3. Now, truly order doesn't matter if you picked 3, 11 to be the second point and negative 2, 4 to be your first point. You could flip-flop the points. Just keep consistent when you're working with your slope formula. Now, 4 minus 11, that would give you negative 7. Negative 2 minus 3 minus 5. Notice we have a negative divided by a negative. That's really like negative times a negative, which creates a definite positive value. And 7 and 5 have nothing in common. They're both prime numbers. So our slope, I'll label this m again, our slope will be this positive 7/5. Now we need to make the equation of the line. And there's really 2 methods that you could use. You can use what's known as slope-intercept form, where m is your slope, which we found, and this b value here relates to the y-intercept in this way. It is the ordered pair 0b. Okay, when x is 0, y would be a b, your y-intercept value here. So that's what we'll use here. Now we know the slope, so let's just plug in 7/5 into our slope spot. So 7/5 will go right there. Now notice there's an x and a y. X and a y relates to our points, and we have 2 points. It does not matter which point you pick. Now I'm going to pick the nicer point with just positive values. So a positive 3 and a positive 11. But keep in mind, you could pick the other point and you will get the same answer. Because with a line, they're going to be crossing through these 2 points directly, linearly together. You'll get the same value. Now, let's start cleaning this up. Here we have a fraction times 3. Now 3 really is divided by 1. So multiplying fractions, multiply through the numerator, 21, multiply through the denominator, 5. And you have plus b. Okay, so then I'm going to scroll down so we have plenty of room to see what happens next. We need to try to solve for the b value so that we can get our b up top. So 11 minus 21 over 5 equals b. You subtract, I should show that. I will subtract 21 over 5 and subtract 21 over 5 from both sides. So my left-hand side now looks like this. You could treat 11 as 11 divided by 1, and you're subtracting 21 over 5. In order to subtract fractions, is what we truly have here, we need a common denominator. What will you multiply this 11 by to get a common denominator? So think about it. Look, we need to multiply by 5 over 5. Really, you're multiplying by 1, which creates a different value for us in the numerator, 55, 5 times 11, and then you're dividing by 5, minus 21 over 5, we didn't change that, will be our b value. Subtracting fractions, we have a common denominator now of 5. 55 minus 21 will be 34 over 5. So our b value, our b, which is the y coordinate of the y-intercept, we know that 0.34 is actually another point on this equation of line. Okay, so let's keep going. We need to make the equation though. We have the slope. We know slope, which is 7/5 from before. Now we also know the b value is 34 over 5. So if we just rewrite the slope-intercept form, I am just going to directly plug in the 7/5 there, put the x, and then plus 34 over 5. Okay. Now, this is truly a solution, but this solution is in slope-intercept form. Remember, we want to go to standard form. And standard form looked like this. And if you recall what I said earlier, the ax needs to be positive. Also, I said earlier that the a, the b, and the c, a, b, and c, need to be integers. Do we have integers here? Right now, you could look here. Really, the only integer that exists is a 1 with the y. But now over here, we have fractions. We have rationals. This is not good. How can we make the a, b, and c, how can we manipulate this to make only integers? What we need to do is multiply everything by this 5. Because if you multiply by 5 and distribute it in, the 5 divided by 5 will cancel out. The 5 divided by 5 will cancel out. Left hand side, you multiply by 5. 5 times the y will make a 5y equals 7x plus 34. See, that cleaned up real nicely, and now it's easier to work with. We still want to keep whatever's in front of the x, the coefficient in front of the x, needs to be positive. And right now we have a positive 7. So I'm going to keep it there. And what I'm going to do is move whatever is with the y to the other side. And then the constant, which is just like the c, by itself needs to move to the other side as well. And by cleaning that up, you have on the left-hand side negative 34 equals, and then I put the 7x minus 5y. Now, are we in ax plus by equals c standard form? Yes, we are, but you may be wanting to rewrite it as this so you can more clearly see that it is in ax plus by equals c form. Our a would be the 7 right there, the b would be the negative 5, and the c is our negative 34, matching our form.